All right, so 4.1, scatter diagrams and correlation. So we start off with scatter diagram, a graph that shows the relationship between two quantitative variables measured on the same individual. Each individual in the data set is represented by a point. I'll draw some later in a second. In here we have the response. Let me do this. We have the explanatory variable. And we have the response variable. All right, so those are our two variables. And let's talk about the difference between the two. All right, so difference between the explanatory variable and your response variable. Your explanatory variable explains the value of the response variable, and your response variable is explained by the explanatory variable. When we get into examples, you'll see what is meant by that transaction. Also, your explanatory variable could be your x variable versus your response could be your y variable. Explanatory is domain, response is range. You have input versus output, independent variable versus your dependent variable, horizontal axis and your vertical axis. And then one more, this is your predictor. And this one is your predicted. All right. So just a general idea of what a scatter plot would look or could look like. So just some points on the positive, or the first quadrant or your XY axis. All right, questions before I scroll up. Make sure we're okay. All right, so next you're talking about your linear relations. Linear relations just when a line best sums up the shape of the scatter plot. So let's look at a few. All right, so once again, linear having a linear relation or a linear relationship just means a line best sums up the shape of the scatter plot. So when we look at the first two, it is a line that best sums up the relationship or the shape. Non-linear, here we have an arc, here we have like a wave. So the statement that I'm about to write down here that I started, non-linear does not mean no relation. It just means no linear relation. All right. So like I said, in the second, on the third and fourth one, they do have a relationship. You can see the pattern. They just don't have a linear relation. And then that last one is an example of not having a relationship at all or relation. All right. All right, let's look at associations. All right, so when we look at our associations, we have relations that are positively associated and then ones that are negatively associated. So when it's positively associated, it's just saying that when one value increases, the other one increases. So if I follow my scatter plots or my points from left to right, if they're going up, then that's positively associated. Negatively associated, when one value increases, the other decreases. So following my points from left to right, if they are going down, then that's negative associations. All right. Uh, all right, so your linear correlation coefficient is a measure of strength and direction of the linear relation between two quantitative variables. All right.
Is that RHO next to the P?
Yep, row. Yep,
Okay.
Greek letter row.
Now I wonder who played. Hmm.
All right, so that P, if you're a baseball fan, looks like the P in Phillies. It's Greek letter row, so it's not actually a P, but that represents the population correlation coefficient. Letter R, and I put same. Sorry about that. That's it. I meant to put sample. That's the sample correlation coefficient. All right. Now the formula is involved, but this book is not requiring you to know how to calculate and use the formula or to calculate it by hand. So just like I did with the standard deviation and the variance, you need to find a calculator, website, app, or something of that nature that can produce correlation coefficient. And what's my other one? What's my other one? Regression line. So regression lines out of 4.2. Correlation coefficient is out of this section. So we haven't talked about a regression line yet, but I'm just going ahead and put it out there. That, and just like before, easycalculation.com can do it. But all you have to do is Google regression line calculator or correlation coefficient calculator, and a whole bunch of free stuff will pop up in order for you to be able to do so.
Where was this information when I had quantitative reasoning?
Oh, I don't know. Sorry. All right, so let's look at properties of the correlation coefficient. All right, so got about 7 or 8 of these properties. So before I scroll up, first it is between -1 and 1 inclusive. That means it can be equal to +1 or -1, but most definitely between those two values. If R is equal to +1, then a perfect positive linear relation exists. If R is equal to -1, a perfect negative linear relation exists. So for this fourth one, the closer R is to +1, the stronger the evidence of a positive yeah, a positive association. Or no. Okay, so the closer R is to +1, the stronger the evidence of a positive association. The closer R is to -1, the stronger the evidence of a negative association. If R is close to 0, then little or no evidence exists of a linear relation. And this is emphasizing what I mentioned earlier. R being close to 0 does not imply no relation, just no linear relation. So if R is close to zero, then little or no evidence exists of a linear relation. R being close to zero does not imply no relation, just no linear relation. 7, it is a unitless measure of association. In other words, you're not going to have inches or miles or meters attached to it, just unitless. And 8, it is not resistant, so that means it is affected by outliers. Talked about outliers before. All right, so here are just general examples. Of course, when you're talking about drawing your scatter plot or your scatter diagrams, you actually have points that will be graphed, and it's just not somebody just making general points. So the first one is an example of a positive linear, perfect positive linear relations, a straight line that's R equal to 1. And as you deviate away from that line, it starts to move further away from 1 and start to go closer to 0. So that's where you see how once it expands a little bit, that's going to be approximately 0.9. And then as it expands more, be zero point 0.4. But you can still see how there's an upward pattern or a positive pattern. So same thing happens in the negative side of it as far as your negative associations. Going in a straight line will be a positive -1. Start to expand from that and deviate from that will move you closer and closer to 0. That sixth one, there is an association. Here's the arc, but R will be close to 0 in this case because remember, R represents a linear association. So this would not be a linear association, even though there is some type of association or some type of pattern here. And then one more. Just stuff all over the place. R would be close to 0 in this case as well. And in that case, there's no relation.
You got to make sure you put this on the website because I see a whole lot of dots and arrows that I'm not going to remember right off the bat.
Well, see, what's going to happen is, though, you're going to have numbers. Once you put some numbers to it, it'll fit better
Yeah,
in your mind.
just recall, the different directions and stuff. I'm not
Mm-hmm.
going to put it right off the top of this school. I'm going to have to
Right,
look.
right. I got you. I'm gonna most definitely make sure. You know what I'm saying? You guys get a copy of this for sure. Yep. So, and in that, with that note, with that, and being in regards, sorry, scratching my eye and all the stuff, I itch, whatever. So, with that being said, even with the scatter plots, don't forget you can always Google scatter plot diagram or whatever. There's plenty of stuff out there that, let's say if my math lab say which one is the scatter plot, let's say you're not that good with graphing, all you gotta do is Google it. There's a scatter plot diagram drawer for you, and you can just type in the data values and it'll draw it for you or plot your points for you. So, all this stuff is out here. And the reason why, I'm not forcing you to do stuff by hand is because, let's say if you were in the workplace, you wouldn't be forced to do it by hand there either. You would have some type of program that they would have taught you how to use, and you would go from there. So, just trying to make sure there's real life application and real life situations when it comes to.
This will not be in my real life. I can assure you.
You never know. You never know.
Um, I'm at the bottom of the ninth with school. This is where the book stops. I don't understand why they made me take quantitative reasoning before statistics. It seemed like I should take statistics first, right?
um, I think you could do either or, and really it depends on the teacher.
Yeah, because I
Um,
knew this was ever explained. It
oh,
wasn't explained like this, let's say that way.
right, 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 right. Yeah, don't know why. Um, but yeah.
Going back in silent mode.
Look, I'm gonna go in silent mode too on that one.
Mr. Tucker,
Mm-hmm.
it says that I'm supposed to request recording permission from the meeting host
All
to
right.
record.
Well, I recorded them anyway, and I shoot them to
Oh,
you. Yeah. Uh-huh.
oh,
Yeah.
thank you, sir.
Yeah. No problem. Just in case anybody else missed that first day or whatever. A lot of moving parts. So I completely understand. If you check in Canvas, I've sent all the emails out to everyone that I've sent from the beginning of class. I posted them in Canvas under your announcements. Make sure you guys see that. If you don't see that, let me know so that I can let others know that there are holes in Canvas programming and all the stuff like that. But you guys, no matter what time you actually log in for the course, let me say this, like, just register for the course. Let's say you get in 2 weeks late, you should be able to see all of the emails that were sent in the class announcements from the beginning of class. So that's why I put them. That's why I email them and I put them in Canvas. So if you're not seeing those, make sure you guys let me know. And, especially for those who come in, have been registered late or whatever. Let me know so I can know what I need to tell, the tech people and all that good stuff like that. But check
Thank
it
you,
out.
sir.
Yeah, no problem, no problem. Every class that we have had has been recorded and posted, and there should be a YouTube link for them. So just let me know if you don't see them, and I can shoot those to you, in an email as well. So yep. Absolute value.
Didn't mean to take up your time.
No, 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 you're fine because someone else could have had the same question or issue, and so no, most definitely I welcome those type of interruptions. They're not bad, interruptions to me. So yeah, thank you, appreciate that.
This has been so crazy since the beginning of the semester, so a lot of people are missing out on, a lot of stuff.
Right, right. Mm-hmm. Variables, not values. All right, so testing for a linear relation. First, we want to determine the absolute value of the correlation coefficient. Then we want to find the critical value from appendix A for the given sample size. So appendix A is in the back of the book. And appendix A, sample size, critical value from, and I should have put in there table 2. It's table 2 in appendix A. So table 2 in appendix A for the given sample size. And if I have a copy, I think I have a copy of that. If I can find that copy, I'll shoot it to you guys in Canvas and in an email. If the absolute value of the correlation coefficient is greater than the critical value, a linear relation exists between the two variables. Otherwise, no linear relation exists. So I'll give you a chance to finish writing, and then we'll do an example. All right, so we want to determine whether a linear relation exists between the club head speed and distance. So we have the club head speed, and we're talking about a swing in a golf club. There was a part of this when we were talking about golf pro wants to investigate relationship and all that stuff like that. So we're talking about a golf pro swinging his club, and the club head speed is these different data observations: 100 miles per hour, 102 miles per hour, swung it at 103 miles per hour, and so on. Then the distance it traveled when swung at those speeds. So just to reemphasize the relationship here, your club head speed is your explanatory variable. Your distance is your response variable. So how fast he swings the club dictates how far the ball travels. So that's going to matter when we go look at the next section, everything like that. Which one is your explanatory, which one is your response will matter, as you plug in and go through your calculations. All right. It doesn't matter in this example. Like I said, I was just re-emphasizing that relationship between explanatory variable and response variable, but it will matter as we progress forward. So this is your data set. So has everybody calculated before I go to another screen? I mean, I calculated, wrote down before I go to another screen.
Yep. Yep.
All right, so I'll show you how we can do this. So, well, let's go back here. Let me write this. Step one, want to find the correlation coefficient. So, all right, so you want to Google correlation coefficient. Let's do that first. Calculator, you can do it that way. And so you have things that pop up. Now, like I told you, what I like to do is correlation coefficient and just do easycalculation.com. All right. Okay, about to say. All right, so here we go. Notice you have your X value, Y value. Remember I told you your X is your explanatory, your Y is your response variable. You can add columns, just moving a little slow. Okay, there we go. And you can take them away, if you don't need them. Said columns, I meant rows. So I'm going to type in those data values. Make sure you're typing in the correct data values, because if you write one of them wrong, of course, it will make the whole thing incorrect. Once again, you do not have to use this. This is just one that I know that works and pretty easy and straightforward. So we got 100, 102, 103, 101, 105, 100, 99. Add one more column, 105. All right. Then the corresponding Y values, or the distances that the ball traveled: 267, 264, 74. All right, so that's your correlation coefficient, and my math lab will let you know how many decimal values you need. Questions on that before we go back to our problem?
Nope.
All right, so let's we got 9, 3, 8, 6, let's go 939. So R is 0.939. So then we're going to take the absolute value of the correlation coefficient. Don't forget what that means for us when we do the absolute value. Just randomly, maybe I'll do it over here. The absolute value of 3 is 3. Absolute value of -3 is also 3. So basically what they're trying to do is ensure that you are looking at the positive result or the positive representation of your correlation coefficient. Because remember, your correlation coefficient can be negative. They want you to compare it to a positive. Take that positive result and compare it to your critical value. So I'm going to do the absolute value of R, which is going to still just be the 0.939. All right, questions on that? Let me see if my MATLAB is still up. Okay, if I thought about it, I would already had this pulled up. It's all good. All right, so here's our e-text. And I think I can type in just A. See if it, nope, that's not good enough. Is it A1? All right, let me see how to label it. Sorry guys, trying to find this appendix page and how they label it. See, maybe it's A-1. I know it's something like that. Okay, yeah. So that's table 1, but we need table 2. So you can go into your text and go to the page and type A-1. Oh, well, we know it's right now A-2. That's table 2. So this is the table 2 chart that they're talking about. Now let's go back to our notes, to our example. We'll come back to that chart. So what we need to do is find the critical value. From table 2 and appendix. And like I said, we just saw that that is page A-2.
I'm trying to pull it up, but Pearson is moving ultimately slow.
Yeah, that's what was taking me so long. Pearson was moving slow. Didn't anticipate, that it would be that slow. So first thing we need before we go to the chart, though, we do need our sample size. That's N, and you get that from your chart. You got 1, 2, 3, 4, 5, 6, 7, 8 observations. So remember that this right here represents one observation. This is my second one, third one, fourth, fifth, sixth, seventh, eighth. So, both those values represent the one time, a time that you swung the golf club. So you have 8 different observations here. So n is equal to 8.
Where are you getting those numbers from?
You talking about the golf club?
Mm-hmm.
That's from the example. That they gave those to you.
I just see table 2 chart.
Oh, you still there? Oh, I'm sorry. I meant to share my screen. Sorry about that. I went back to your notes.
Okay.
Sorry about that. So you see my note. You see the note screen now, right?
Yep.
Okay. So I don't know if it just didn't click over or whatever. So yeah. So here we go. Our observations, number of observations we have. We have 8 times that he swung the golf club. And so what I was saying is that 100 and 257 represents one time that he swung a golf club. He swung it 100 miles per hour and he got 257 yards out of it. So don't count each one of these numbers to get 16. You actually only have 8 times that he swung the golf club. All right. Any questions on that? So that means n is equal to 8. All right. So from that, should be able to go to the chart now. So let me reshare that screen. All right. So when n is equal to a certain number, notice it starts with 3 and goes to 30. So when n is equal to 8, the critical value that they give is 0.707. All right.
Okay, that's why I was asking because I was like, the chart says 0.707.
All right. So, but everybody good now, right?
Yep.
All right. So go back to the notes. Chart. Yeah.
You see now?
Say again now.
I get out of Pearson now.
You asked me, are you getting out of Pearson?
Can I get out of it?
Oh yeah. I was just doing this to show you guys what the chart looked like.
Oh,
If I can find the picture that I have of that, then I'll send it to you anyway. But at least you know where to find it is on page A-2 in your appendix.
mm-hmm.
All right. So now compare absolute value of correlation coefficient and that critical value. So we're going to compare the absolute value of the correlation coefficient and that critical value. So we know the absolute value of the correlation coefficient is 0.939. Our critical value, 0.070. When we look at the relationship, absolute value of correlation coefficient is greater than critical value. All right. Do our conclusion now. Go back to what was said. I'm gonna scroll back down. Just want to make sure we look at step 3 and determine. We have a couple more steps because we're doing all of the process. But it says if the absolute value of the correlation coefficient is greater than the critical value, a linear relation exists between the two. Otherwise, no linear relation exists. So since the absolute value of the correlation coefficient is greater than the critical value, than a linear relation. All right. Since the correlation coefficient, the absolute value of the correlation coefficient is greater than the critical value, then a linear relation exists between the club head speed and the distance the ball travels. All right. All right. Questions on anything that has been said today? That is 4.1.
No, sir.
Test 1 and 2.
All right. So again, did I hear two voices there?
I said no, sir.
Oh, okay. Appreciate that. Appreciate it.
One question,
Yes.
when do we take the test?
As soon as possible.
Oh, it's up for us?
Yep. Yep.
I don't see
Okay,
All
I
right.
thought we were gonna have to go somewhere.
No. Not for your final exam. No, for your final exam, I will proctor that. And you still wouldn't go anywhere. It's just that everybody would log on to Zoom, whatever day we set for it. And then you would make your cameras available, your video available. And then so that I'll be able to see you. And, we'll talk about that as we get closer to that time. But that's how I would do a test that need to be proctored. I still wouldn't send you out anywhere, though.
Oh, thank you.
Yeah, no problem. So let me show you this just to make sure everybody's on the same page. Hopefully
where is test 1 and 2 posted at?
that's what I'm about to show you.
Okay, let me sit down here.
You funny. All right, let's see. That's the wrong screen. All right, here we go. So you guys should be able to see my math lab. And if you click quizzes and tests right here. Really? So yep, I have all of them posted right now.
Can I take all of them?
Yeah, man, do your thing. Yep. So notice you get 2 chances to get the best grade possible. And test 1 does not have a test review because majority of it, or say a lot of it, are definitions. So there's only but so many ways you can get a definition right or wrong. I mean, so test 2, 3, 4, and 5 though. And we may get to chapter 10, we may not. I know we're going to get to chapter 8. I know for a fact we're going to do that. So I know for a fact you're going to at least have 4 tests. Not so sure about the 5th one, but we'll see. But each one of those have a test review that's before it that is very similar to it, and it'll help you study for it and see what questions you need to ask before you actually get in there.
Can we get at least 3 attempts?
Say again now.
Can we get at least 3 attempts?
This is what you do. If you take it 2 times and you still didn't get the grade you want, you come see me. We'll talk about it.
Okay, thank you. That's good enough for me.
And then also notice down here, under here, it has sample tests and quizzes. I could not remove those, so please do not take them unless you just want to do some extra stuff. I don't even know what's on them, but there's stuff that my math lab have up there that I could not remove. So if you see anything that says pre-test, review quiz, post-test, pre-test, you see that stuff, I didn't label any of that. I didn't create any of that. The only thing that you have are tests and homework. Those are the only labels, tests and homework. And like I said, your test reviews are set up as a homework. So the only things that you guys have are tests and homework in my math lab. So if you see anything that's labeled pre-test, post-test, quiz, that's not me. That's something that I could not get out of my math lab. So, but always, if you have any questions about that, feel free to shoot me a question, ask, or email or whatever the case may be. All right. Questions, concerns, comments before we close out?
No,
No, thank you.
Yep, no problem, no problem. Notice I also, one last thing, I have not put a due date on anything yet. It just says December 11th. So take advantage of that, get in there. And I don't know if I'm gonna do due dates because everything's so crazy, but you don't want to sit around waiting until a due date show up and then say, oh, now I need to do it. You know what I
I
mean?
already started on mine.
Yep. This sounds like a good plan. So
Look, I know I'm old and slow, so I can't wait till the last minute on that.
get out of here. You all right? So if everybody's good, I'm good. I will see you on Thursday. You guys have a good one and take care.
You too. Bye bye.
All right.